Tell me the answer to this DOM. 14 is the correct answer. How did you get 14? Plug it in. And that's what we're doing all day today. We're doing more limits, and you're just going to plug them in. And the only time you have to do something other than that and do the point check is when you get a 0 in the denominator. So just more of the same. You plug 3 in for x, yeah. Yeah. You plug whatever the number is for the x. Now, on number 1, where does the 2 go? Nowhere. There's no x. It's one of those stupid ones. Yeah, the answer is just 8. All of these, you just plug in the x, and then you either say it does exist or it doesn't exist. Well, you don't have to say it does. You'll give me the answer or say it doesn't exist. Yes. Yes, it is. Yes, it is. Take a look at some of these examples and raise your hands if there's certain ones you'd like to see, because they look just more troubling than the others. Not all of them. What? The cubed one. Good question. Actually, you'll do it the same. You talk about number 11. 5 times 2 minus 8 cubed. So that's 10 minus 8, so it's really just 2 cubed. 35, I will, and I'll also do 27 in passing, because even though nobody's asking, I bet people are thinking, that looks ugly. What if I get 0 over 0? 27 is a perfect case of you can do the point check on your calculator. Do the y equals and then take points on either side. Of course, 27 will actually factor as well. If you like to factor, the top would factor by grouping, as would the bottom, if you choose to do it like that. Does anybody want to see 27? How to do what? Okay, I'll show 27 both ways. First, if you chose to factor, let's see, the top, after you factor by grouping, would be x squared times x minus 2 plus 4 times x minus 2. And the bottom would be x squared cubed. X cubed times x minus 2 plus just regular x minus 2. That's if you chose to factor by grouping. And then you could plug 2 into that, and you would get 4 plus 4 is 8 over 8 plus 1, so 9. So the answer to 27 would be 8/9. Yes, I did. Once I canceled off all the x plus 2's, I just plugged 2 in. Just remember, when this cancels, it's not a 0, it's a 1. Yes. Yes. Somebody just asked. We're going to do 35 in just a second, but I thought I'd hit 27 just to stay chronological. I will show the point way, but first I'll go ahead and show it with my number 27 problem. Where's my calculator? Debug. Go. Oh, there it is. All right, so we know the answer is 8/9, and the calculator usually gives that to us in a decimal. What is 8/9 as a decimal? Isn't it just like 0.8 repeating? Yep, it is. All right, so first let's do the numerator. X cubed minus 2x squared plus 4x minus 8 close. Divided by quantity x to the 4th minus 2x to the 3rd plus x minus 2. 2. And graph. Boom, there it is. Now we're looking at x equals positive 2, which I bet if we trace that, it'll say it doesn't exist. So, the point check way, we need to take a point on either side. What's a number just ever so slightly less than 2? 1.99999. Does it look like it's going to 8/9? Yes, it does. 0.8 repeating is what we're going for, and that's pretty darn close. Now let's try a number just greater than 2. What's a number just greater than 2? 0.00001. 1. Thank you. Enter. Does that look like it's going to 8/9? You're incorrect. All the 8s imply that it does. So your answer would be 8/9 no matter how you did it. Of course, if you wanted to write on your, say you just did point check way, I don't care if you just put 0.88888 on there, that's the same difference. Questions about how we did 27 either way? No? All right, let's look at a different one. 35 was the one I heard, so let's look at that one. Basically, you're going to want to try the point check one anytime that some kind of way to factor doesn't just stick out to you. Like, for instance, 33, the one Chris asked about, that looks kind of crazy to factor. I mean, it can be done, but that's definitely one that I would just do the point check form, because you're going to get 0 over 0. In fact, let's just do that real quick. Point check is quite... Anything over 0 is something you can't determine. So that's why you have to do the point check form, or factor. That basically finds the answer that you couldn't get by plugging it in. That's all it does. You weren't here Friday, were you? So you have no idea what we're doing. I'll talk to you later. Okay. Well, I'm going to talk to people who were here, and then I'll help all you guys a little bit. But it really, all we're doing is plugging in numbers. You just plug in whatever number it says into the function. Okay, I'll explain the backstory with it later, but essentially all we're doing is plugging that number it says into the function. If it gives us a number other than something over 0, that's the answer. But if we get a 0 to the denominator, regardless of what's up top, you have to check it a different way. So, all right, here's the backstory. It'll take like 10 seconds. Essentially, for every point we can't determine on a graph, you can find its limit. These LIMs mean the limit, which means what is the graph getting really, really, really close to at that point. So like the last one we did, that point didn't exist, but the graph was narrowing in on the point y equals 8/9, which is what we got when we plugged it in. So same for this one. You plug in 4 for 33, you get 0 over 0. So now we're going to graph it and see what that point is actually going to.
So just to clarify on the last one, you were going 4, 2, and 8/9, right? But you never actually really touched that chord.
Because it didn't exist. That's right. We're seeing what it's going to really, really closely so we can estimate what that answer would be. That's what a limit is. So like this one, I plug in 4. Notice, no answer, which we already knew because if you plugged in 4, you get 0 over 0. So what's a number really, really close to 4 on either side? What's a number ever so slightly less than 4? There you go. Trace. 3.99999. It looks like it's getting closer and closer to what? 0.25, or what is that as a fraction? 1/4. Let's try a number just greater than 4. What's a number greater than 4? That's right. And it is also getting really, really, really close to 1/4. So the answer for this one would be 1/4, and that's all you have to do. 33. 1/4. 35 is going to work very, very similarly. But we can plug that one in too. Let's see. Y equals. Now you're going to need lots of parentheses. One for the entire numerator, the other for just our smaller fraction first. 1 divided by x minus 1/2. Close off the entire numerator. Divided by denominator x minus 2. Close parentheses. Wrap. There it is. Trace. I'm guessing at 2 it doesn't exist. And it doesn't. So I need to try points on either side. 1.999999. Enter. Looks like it's getting closer and closer to what? Negative 1/4. Negative 0.25. So let's try something on the other side. 2.000001. Negative 1/4 again. So negative, if those numbers are not the same, then your limit doesn't exist. If one says negative 1/4 and the other says negative 7 or anything different, then they don't exist. But if they're honing in on the same number, then that is your answer. No, 0 over 0 is an indeterminate number. So yeah, for 37 you can just plug into. 39 you'd have to do the point check. Is there another problem on here that somebody would like to see work? You can try factoring and see if that'll help your problem. Or if you don't want to do that, you can just jump straight to the point check. No other questions? Okay, the only other slide we have is the same exact thing except more piecewise functions. So let's look at 49 first. The reason I'm starting with 49 is 49 contains something that I said we will absolutely never need when looking at limits. Actually, let me read the directions before I jump straight into what I think we're doing. Okay, use properties of limits to find the indicated limit. And then, okay, so yeah, you do not care what the point equals at our limit value. We don't care. That's not the point of a limit. The point is to see where it's going. So, I need to find the limit as it approaches 1 from the left. Now, for you people who weren't here the other day, what did we just do in the calculator? We took a point on either side, right? Right, left side and right side. Well, that's all this is. This says what is it from the negative side or the left side. This says from the right side. So instead of taking both like we just did in the calculator, you'll just do one of them. So, to find it from the left side, which of these two functions talks about numbers on the left side of 1? The top one. So you plug 1 in for this, and what do you get? 0. Now, there's no denominator, so that's a perfectly legitimate answer. This one is 0. What do you get if you plug it into the bottom one? 0. The final one, exactly. If they're the same, then that'll be it. Then it doesn't exist. Because that implies one of them is here, and the other one is here, and they just... If you go back and watch the videos from the last few lessons, you hear me say that a lot. You hear me say if they're here and here, and I realize you can't see what I'm doing, but that every time I'm doing that. Because it means they're going to different places. Okay. 47. What piece of that do we not care about one bit? The bottom one. We don't care what x equals, or what y equals and x equals 3. We're only caring about what it's going to everywhere else. So even though this says the piecewise, essentially this is your function, and this just random point is somewhere else. So you'll plug both of these into the same equation. Again, same thing is down here. If they're the same, that's your answer. If they're not, then
Well, shouldn't A and B be the same?
not necessarily.
I don't know. Let's say 3.
Yes, but one talks about from the left, one talks about from the right. And here's what's happening. See, you get a 0 in the denominator there. You might have a situation like this. Well, I don't want to get too complicated because we haven't talked about this very much yet. But you might get something like this, where one comes down and stops here, and the other one might pick up here. And see, then your left-hand limit would, let's call this -3. Let's call this +3. I'm completely making up these numbers. Don't wonder where they're coming from. But you might say, well, the left-hand limit, as I come in from the left, was -3. And as I come in from the right, was +3. But the overall limit doesn't exist since they go to two different places. If you weren't here the other day, let me just summarize the entire first section as this. This entire section and the previous one, the one you missed, is nothing more than using context clues to find out what points should be, assuming we couldn't see that exact point. Imagine that one little place was wiped out. The whole thing is there enough context clues to let you know what that point would be? This one, the one I've drawn, would not be. Because without seeing that point, you wouldn't know whether it was actually down here or up here. But if they were the same, if they're both going to the same spot, then you could assume that that would be your point. Look at the screen. Is there another letter up here or number that you'd like to see work? Yeah.
It has the negative sign after 1.
That means from the left.
That goes to left side?
Yes. Yes, it does. Good question. And the plus goes to greater. You're welcome. Other questions? All right. Well, that's it. There you go. See, it's practically a